Welcome on this tutorial. Wish all you are well. In this tutorial, I am going to discuss different numerical problems on Norton's theorem and their solutions. And also, I have used Proteus software to check whichever I have calculated different values, whether those values are correct or not. Go through the full tutorial. It will be very much helpful for you. Subscribe my channel. It will encourage me to upload more and more valuable tutorials. Entering into the discussion. Problem 1. In a given network, draw Norton's equivalent circuit and find the current through 18.75 ohm resistor. So here the problem is to find out the current through this 18.75 ohm resistor. We need to use Norton's theorem. So first stage is to draw the equivalent circuit. This is the Norton equivalent circuit. Except the load resistance, that is 18.75, the rest part of the circuit should be converted to single current source and a single resistance, and that single current source and single resistance will be connected in parallel. So this part and this part are equivalent. So this is the Norton equivalent circuit. What we need? We need to find out the Norton current and we need to find out the Norton resistance. Next step is to find out Norton current. For that, what we will do? We will short the load and find the short circuit current. This is the load. So for finding out the Norton current, we need to short this resistance. So this, I have shorted this, and whatever the current will flow through this shorted path, that current is the value of IN. So this will be the circuit for finding the IN. Here on current source, and these are the resistive network. To find out the IN, we are considering three loops: I1, I2 and I3. This I1 will flow through this loop, I2 will flow through this loop, and I3 will flow through this loop. Here I1 is flowing through this loop, so value of I1 is no doubt 30 ampere. Similarly, I3 is flowing through this loop, so I3 is equal to IN. Now by using KVL, we will find the different equations from different loops, and we need to solve it to find ultimately the value of I3. So this is that circuit. From mesh 2, I2 current is flowing in upward direction and I1 current is flowing in downward direction. So net current here flowing through this 10 ohm resistance is I2 minus I1. This I2 minus I1 multiplied by 10 resistance. So this is the voltage drop across resistance R2. Through this resistance I2 current is flowing in this direction. So I2 multiplied by 5. This is the voltage drop across the resistance 5 ohm. Next here I2 is in this direction and I3 is in this direction. So I2 minus I3, this current is flowing in downward direction. So voltage drop across this resistance 5 ohm is equal to 5 multiplied by I2 minus I3. So this is the voltage drop across 5 ohm resistance. So here the voltage drop, current is in upward direction. So this is positive, this is negative. Here current flowing from left to right. So this is positive, this is negative. Here current flowing from up to down. So this is positive, this is negative. So here plus minus, plus minus, plus minus, and this is also plus minus. So the source voltage and the voltage drop all are in same direction. So summation of this 4 will be equal to 0. So this is the equation I got from this loop. After simplifying this, I got this 4 of I2 minus I3 is equal to 50. This is equation number 1. Now from mesh 3, I3 current is flowing through this upward direction and I2 is flowing in downward direction. So considering the current which is flowing I3 minus I2, this is in upward direction. So voltage drop across this 5 ohm is equal to 5 into I3 minus I2. So in this loop, loop number 3, the potential drop, this is positive, this is negative, and here this is negative, this is positive. If we consider this is positive, this will be negative. So this minus this is equal to 0. this 50 voltage will be equal to 5 into I3 minus I2. From this we got this equation. By solving equation number 1, equation number 2, we got the value of I2 is equal to 20 ampere and I3 is equal to 30 ampere. Now I3 is Norton current, so value of Norton current is now 30 ampere. What we need next? Next we need to find out Norton resistance. To find the Norton resistance, what we need to do? Open the RL. So this resistance will be open. Say I have opened this one, and all the sources will be replaced by their internal resistance. Two sources are here, current source and voltage source. No internal resistances have been mentioned here. So considering voltage source and current source both are ideal. For ideal current source, the internal resistance is infinity. So this will be open circuit. Say this is open circuit. And for ideal voltage source, internal resistance is 0. So this will be short circuited. So this is short circuited. So for finding out the Norton resistance, the circuit is this one. Now if we look from this terminal through A and B, whatever the equivalent resistance we will get, that is the Norton resistance. Now see here, this 5 ohm and 10 ohm, these are in series. Equivalent of these two is in parallel with 5 ohm. If we cannot understand, then this circuit can be redrawn with an easier way. How we will redraw it? From this A, we will start to walk. So say this is point A. When we will start to walk, when we will come to here, we will get two paths. One is 5 ohm, another one is this 5 ohm. So after having a walk, we will get two paths. In one path, one is 5 ohm, in another path, another one is 5 ohm. This is 5 ohm, this is 5 ohm. Now this 5 ohm is connected with 10 ohm. So again this is connected with 10 ohm. And after that, this is coming to terminal B, and this 5 ohm is coming to terminal B. So say this is coming to terminal B. Now it is very easy to understand that this 5 and 10 are in series, and equivalent of this one is in parallel with this 5 ohm resistance. So the whole circuit is now can be converted into this circuit where 15 and 5 are in parallel, and ultimately equivalent of this one is 3.75 ohm. So Norton resistance is 3.75 ohm. What is the next stage? In next stage we need to put Norton resistance and Norton current in equivalent circuit, and ultimately we will find current through load. What is the value of Norton current? Say we got the value of Norton current is 30 ampere, and what is the value of Norton resistance? It is 3.75 ohm. Now putting those values in equivalent circuit, this is Norton current 30 ampere, this is Norton resistance which is in parallel, and this is the load resistance. Now we need to find out the load current from this circuit. How we will find the current? Here see, this is the main current which is flowing here. This main current is divided into two paths. This is one path, this is another path. If the main current is I and this current is I1, this current is I2, what will be I1? I1 is equal to, I1 is flowing through this RL and I2 is flowing through RN. So I1 will be opposite path resistance, this is RN, divided by total resistance of these two, summation of these two, this is Rn plus RL, multiplied by the main current. Similarly, what will be I2? I2 is equal to other path resistance, this is RL, divided by summation of these two resistance, RL plus Rn, multiplied by main current. So using this formula, I am finding out the value of IL. So here opposite path resistance, this is 3.75 ohm divided by 18.75 plus 3.75, this multiplied by main current which is 30 ampere. So ultimately IL is equal to 5 ampere. So this is final answer. Now I will check whatever the calculations we have done, whether this is correct or not. I am using Proteus simulation. This is my original circuit. I have drawn the circuit here. See, the same circuit is this one. This is the same circuit. To measure current through load, I have used one ammeter. And this is the equivalent circuit. See the equivalent circuit, 30 ampere, 3.75, 18.75. So this is that equivalent circuit, 30 ampere, 3.75 ohm, 18.75. Now running this simulation, if the current flowing through this 18.75 ohm in this main circuit and current flowing through this 18.75 load resistance in this equivalent circuit, if these two currents are same, then this circuit is the Norton equivalent of main circuit. So running the simulation, say in the main circuit the load current is 5 ampere and the equivalent circuit also load current is 5 ampere. So whatever the calculation we did, those are perfect. Problem 2, we need to find out the current through the load resistance 2 ohm. So first, drawing the equivalent circuit. This is the equivalent circuit, IN in parallel with RN, and this is the load resistance 2 ohm. This is the equivalent circuit of this one. Next step, you have to find out the Norton current. To find the Norton current, the normal procedure is to short the load resistance. We need to short this load resistance. So shorting this load resistance here, and the current flowing through this short path is the Norton current. So this circuit is the circuit to find Norton current. Now to find out the Norton current, we are considering 3 loops. This is loop 1, flowing the current I1, loop 2 I2, loop 3 I3. Now we will use the KVL in these 3 loops. What is the value of IN? Here I1 is flowing in this direction and I3 is flowing in this direction. So I1 minus I3 is basically IN. So IN is equal to I1 minus I3. Now using the KVL in loop 3, through this 4 ohm resistance current I3 is flowing from left to right. So 4 into I3, this is the potential drop and the polarity is here positive, here negative. Now through 6 ohm, I3 is in this direction and I2 is in this direction. So I3 minus I2, which is flowing from right to left, so 6 into I3 minus I2, this is the potential drop across this resistance 6 ohm, and the polarity will be plus minus. No other sources are here, so this is plus minus plus minus. So if this will consider positive, this will be considered positive, so this plus this is equal to 0. So summation of all the potential drops are 0. So we will get this equation. Here in this loop I have considered I2. Now I2 is flowing in this direction and here 4 ampere is flowing from bottom to up. So I2 is nothing but minus 4 ampere. Putting the value here, ultimately we got I3 is equal to minus 2.4 ampere. Now using KVL in first loop, I1 is flowing in this direction and I2 is flowing in upward direction. So I1 minus I2 multiplied by 4, this is the potential drop across this resistance, and the polarity is here, this will be positive, this will be negative. This is that potential drop across 4 ohm resistance. Now here see, this is minus plus, this is plus minus. So if we consider this is positive, this will be negative. So this minus of this is equal to 0. So we got this equation, and substituting I2 is equal to minus 4 ampere, already we have seen. Ultimately we got I1 is equal to minus 2.5 ampere. So What is IN? IN is equal to I1 minus I3. So this is I1 minus I3. Ultimately we got IN is equal to minus 0.1 ampere. This is Norton current. Next we need to find out the Norton resistance. This is the main circuit. What we will do? We will just remove the load resistance. So load resistance has been removed and all the sources will be replaced by their internal resistance. Here this is shorted, say in this place it is shorted, and as this is the current source it will be open. This is the circuit to find out the Norton resistance. Now if we look from the terminal A and B, whatever the equivalent resistance we will get, that is the Norton resistance. Here 4 and 6, these are in series and combination of these are in parallel with this 4. If we cannot understand it, we can read these things. This is the terminal, we start from here. So say this is that terminal, we start walking from here, we got two paths, this is one path, this is another path. So in one path this is 4 ohm resistance. So drawing this, one path this is 4 ohm resistance, and this is connected with this resistance 6 ohm, and ultimately it comes to terminal number B. In another path, this is another path which is coming here to here, ultimately this 4 ohm resistance and ultimately coming to this point B. So another path, this resistance 4 ohm, and ultimately it will coming to here, this is B. So what is here? This 4 and 6 are in series and equivalent of this one is in parallel with this 4. So ultimately we got 2.85 ohm resistance. So this is Norton resistance. Now we need to put the Norton current and Norton resistance in equivalent circuit. Say I put the Norton current here, minus of 0.1 ampere. This is the Norton resistance 2.85, and we need to find out the current through the load resistance, which is 2 ohm. Using the similar process, current in this path is equal to opposite side resistance divided by summation of these two resistance multiplied by main current. So ultimately we got IL is equal to minus 0.05 ampere. This is the answer. Here I got load current is minus 0.05 ampere. Now checking whether the result is correct or not. This is the main circuit. This ammeter shows current flow through load resistor 2 ohm. This is Norton equivalent circuit. Norton current is minus 0.1 ampere. Norton resistance is 2.85 ohm. Now this ammeter will show current through the load. Now running the simulation and see what is the value of current showing by this ammeter and what is the value of current showing by this ammeter. If these two are equal, then we can say the value of Norton current and value of Norton resistance which we have calculated are perfect. Running the simulation, say it is minus 0.05 ampere, here also it is showing minus 0.05 ampere. So our calculation is perfect. Problem 3, find current through 4 ohm resistance using Norton theorem. Here this is that 4 ohm resistance, here it is mentioned by RL, this is the load. I am using the same procedure. First Norton equivalent circuit, this is Norton current, this is Norton resistance, and this is that load 4 ohm. I need to find out the Norton current and Norton resistance. To find the Norton current, first the load should be shorted. Whatever the current will flow through this shorted path, that is the Norton current. This is the circuit to find the Norton current. Here this 2 ampere current will flow through this path and a current will flow due to the 12 volts supply. Ultimately this 2 will flow through this path, and here the same current is flowing here. That current here having two paths, one path is this one, another path is this one. Now this path is shorted and this is having a particular resistance, so no current will flow through this path. all the current will flow through this path. So we can omit this resistance from the circuit. So ultimately the circuit looks like this. From this circuit we need to find out the Norton current. Taking two loops here, this is the first loop, this is second loop. Now here from the second loop, I2 is flowing in this direction and I1 is flowing in this direction. So I2 minus I1, that will flow from bottom to top. So potential drop 4 into I2 minus I1, and the polarity of this one is, this is plus, this is minus. Next, I2 current is flowing through this resistance. So 8 into I2, this is plus, this is minus. Same I2 current is flowing through this 8 ohm resistance. So 8 into I2, this is plus, this is minus. So 8 I2 and 8 I2, this is 16 I2, which is here. Now see here, this is minus plus, this one is plus minus, and this one is plus minus. So if we consider this one is positive, these two are negative. So this 12 volt is positive and these two voltage drop are negative. So ultimately this is the equation from loop 2. Now here see, from this loop on, I1 is 2 ampere. Putting this I1 is 2 ampere, ultimately we got I2 is 1 ampere. So this is IN, because I2 is equal to IN. So I got Norton current, which is 1 ampere. Next step is to find Norton resistance. This is the load, so this should be removed and sources will be replaced by their internal resistances. So this current source will be open, see here, nothing is here, and the voltage source will be shorted. Here this is shorted. So this is the circuit to find Norton resistance. From this circuit we can see this 8 ohm, 4 ohm and 8 ohm, these are in series, and equivalent of this 3 is in parallel with this 5 ohm. If we cannot understand this, we can redraw it in a simple way. Start working from A, say this is A. From A there are two paths, this is one path, this is another path. So from A we got two paths, one is 8 ohm, next it is connected with 4 ohm, next it is connected with 8 ohm, another path is 5 ohm, and this 5 ohm and this 8 ohm is connected, and ultimately it is in point B. So it is here, these are in series and combination of this is in parallel with 5. So by using this we got Rn is equal to 4 ohm. Now putting In and Rn in Norton equivalent circuit using the similar procedure, I am finding here current through load resistance 4 ohm. So this current is opposite arm resistance, that is 4, divided by summation of these two, 4 plus 4, multiplied by main current 1. Ultimately we got 0.5 ampere. So this is answer. Now showing which calculation I have done here, whether that is correct or not. This is the main circuit, this is the load. Using this ammeter I am measuring the current through this load. This is Norton equivalent circuit, putting the value Norton current 1 ampere, Norton resistance 4, the same load, and this ammeter will show the current through this load. Now if this ammeter reading and this ammeter reading are same, then I can assure that our calculation is perfect. What the output we got? We got IL, that is the load current, is 0.5. Running simulation, see the output. Here it is showing 0.5 ampere, it is showing 0.5 ampere. So I have solved the problem perfectly. Next problem. Find value of current in 4 ohm resistance using Norton theorem. So this is the load here. We need to find the current through this 4 ohm resistance. First step, drawing the equivalent circuit. This is Norton current, Norton resistance in parallel, and this is load 4 ohm resistance. This 4 ohm resistance is here, this is the load. So this is equivalent circuit. Now we need to find out the Norton current and Norton resistance. To find the Norton current, this load resistance should be shorted. So this 4 ohm should be shorted. So this is shorted, all the rest part are same. See here, this is that circuit to find Norton current. Here in this case, the only source is this 8 volt. So this is the main current. Here this current will flow here. It has two paths. One path is this one, another path is this one. Again this current here, it gets one path in this direction, another path in this direction. But here in these two paths, this is short path, and here in this path resistances are there. So all the current from here, it will flow in this direction. No current will flow in this direction. So this portion of the circuit I may omit. So ultimately this is the equivalent circuit. Say up to this is that IN. Now this is the circuit from where I need to calculate Norton current. Considering two loops, first loop, second loop. From first loop, potential drop across this is 2 into I1, polarity is like this. Potential drop across this is 2 into I1 minus I2, this one, and polarity is, this is positive, this is negative, and here this is I1 current is flowing through this path. So here 2 into I1, polarity is this one and this one. So from this, as this is minus plus, this is plus minus and plus minus. So if we consider this one positive, this 3 are negative. So according to KVL, this minus of this minus of this minus of this is equal to 0. So ultimately we got this equation, and simplifying this equation I got this one. This is say equation number 1. Now from second mesh, I2 is flowing through this resistance and it is in left to right. So this is positive, this is negative. Here again 2 into I2, this is positive, this is negative, and here I2 minus I1. So 2 into I2 minus I1, which is this is positive, this is negative. Here no sources are there and all our polarities are same polarities, say positive, negative, plus minus, so summation of all three is equal to 0. So from here I got this equation, and simplifying this equation I got I1 is equal to 3 of I2. Now solving this equation 1 and this equation 2, I got I2 is equal to 0.5 ampere, and this I2 is nothing but IN. So what we got? The Norton current is equal to 0.5 ampere. Next step is to find the Norton resistance. To find the Norton resistance, this is the load, so that should be removed. See here, load has been removed, and the sources will be replaced by their internal resistance. Here this source is voltage source, this is ideal voltage source, this is shorted. So here this is shorted. Now the equivalent resistance looking from here is the Norton resistance. If we cannot understand the series parallel combination here, by the same way which I have already explained, I can simplify this circuit. I can redraw this circuit with simple way. So starting from this point, say this is that point, starting from this point we got two paths. Say left path is 2 ohm and right side is 2 ohm. From this 2 ohm, here two paths, this is one path, this is another path. So here this is again divided into two paths. Say this one I am drawing here, 2. Next this is another path I am drawing here, this is 2. These two is seriously connected with this 2, so another 2 is here, and these two and these two are connected at a particular point. This is that point. From that point, 1 2 ohm resistance is connected. This ultimately terminates to point B. So this is point B. From this side, this 2 ohm, it is connected with these two and these two, and ultimately comes to point B. So another 2 and another 2, ultimately it will come to point B. So this is 2, this is 2. Now it is easier to understand. First this 4 will be parallel with this 2, say this one. Combination of this is in series with 2 and 2 4. So it is this part, and the whole combination of this is in parallel with this 2 2 2, that is 6. So this is in parallel with 6. So by calculating this part, ultimately we got Rn is equal to 2.82 ohm. So I got In is equal to 0.5 and Rn is equal to 2.82. Now putting these two values into equivalent circuit. This is not an equivalent circuit. So In is 0.5 and Rn is 2.82. And ultimately our target is to find out the current through this 4 ohm resistance, which is load current. So this current will be equal to other side resistance, this one, divided by summation of this and this. This is summation of this and this, multiplied by the main current, multiplied by main current. So ultimately we got the load current 0.21 ampere. Now checking whether my calculation is correct or not. This is main circuit. Ammeter is connected to get the current through this load resistance. This is the Norton equivalent circuit. Norton current 0.5 ampere, Norton resistance 2.82 ohm. Now if this current and this current are equal, then we can say our calculation is perfect. Norton's theorem has been proved. What was our calculated value? Load current was 0.21 ampere. Running the simulation and see, in main circuit load current is 0.21 ampere and in Norton equivalent circuit load current is 0.21 ampere. So it proves that the calculation which I did, that is perfect. Problem 5. Find current through 8 ohm resistance using Norton theorem. So this is the load resistance here. I need to find current through this 8 ohm resistance. First step, draw the equivalent circuit In parallel with Rn. I need to find out the value of In and Rn, then I need to calculate the load current. First, to find Norton current, what we need to short load resistance. So this will be shorted. So here, say in place of this 8 ohm resistance, it is short circuit. Now whatever the current will flow through this short circuit, this is Norton current. Now to calculate the Norton current, see here, this is the only source in this circuit. So current will be generated because of this source. So current will flow through this path. This is the main current and it will get different paths here, because this point, this point, this point all are same point. So this I current, main current, will be divided into different parts. This one I1 say, this one I2 say, this one I3 say, and last one is In. What will happen here, this In, this is the current in short circuit path, but for I1, I2 and I3 there are different resistive path. So no current will flow through I1, I2 and I3, all the current I will flow through this In. So to calculate this In, the whole circuit can be simplified as this circuit. Say this is the voltage, this voltage is here, the 2 ohm resistance is here. Next this current, whole current will flow through the In. So the whole current path is through In. So now this is the simplified circuit to find out In. Now what will be In? This current is due to this voltage and only having on resistance. So this current is this 200 volt divided by 2 ohm resistance. So say the value of Norton current is 100 ampere. Next, to calculate the Norton resistance, the load will be removed. So this resistance has been removed here. See here, this is open, and the source will be replaced with their internal resistance. Here this is ideal source, so it is short circuit. Now this is the circuit to calculate Norton resistance. Now here, if we start walking from here, then this point, this point, this point are same point. So one path is through this way, another path is this one, another path is this way, another path is this way. These are all parallel paths. But here, because of the presence of this 20 ohm resistance, we cannot say how this 20 ohm is connected with this 10, 10, 6 or 6, whether it is in series or in parallel. It is very difficult to understand here, or we cannot say this 20 is in series or in parallel with this other combination. So here we use a separate way to make it easy. Here these three resistance 20, 10 and 10, this will form a delta combination. Delta means, say here it looks like this. This is 20, this is 10 and this is 10. It looks like this. So this delta combination, if we convert it into star combination, then that will be easier to calculate the equivalent resistance. Now how we can convert from a delta combination to star combination? Say this is the formula I am showing here. This is the delta combination with the resistances R1, R2 and R3, and this is the star combination with the resistances small r1, small r2 and small r3. So from this combination I need to find out the value of small r1, small r2 and small r3. So what will be small r1? Small r1 is equal to, it is related with this r1, it is related with the point 1, it is related with the point 1 which is related with the resistance R3 and R2. So R1 is equal to R3 R2 divided by summation of this R1, R2 and R3. So this is R1. Similarly, what will be the value of R2? This R2 is, it is related with R3 and R1. So R3 R1 divided by R1 plus R2 plus R3. Similarly, what will be R3? R3 will be equal to R1 R2 divided by R1 plus R2 plus R3. So this is the formula I will use to convert from delta combination to star combination. So here from this delta combination, the star combination configuration will look like this. So this is say R1, this is say R2, this is say R3. So what will be the value of R1? R1 is equal to this resistance multiplied by this resistance, that is 200 divided by this resistance plus this resistance plus this resistance, that is 40. So this is equal to 5 ohm. See, it is placed here. R1 is 5 ohm. What will be the value of R2? R2 is equal to this 20 multiplied by 10, that is 200. Similarly divided by summation of these 3, that is 40. Again this is 5 ohm. So say this 5 ohm. What is R3? R3 is equal to this one. It is related with this 10 ohm and this 10 ohm, that is 100 divided by 40 and it will be 2.5 ohm. So say that 2.5 ohm. So this delta combination has been converted to star combination. Now see, now it is easier to understand. Say this and this is in parallel with this and this. So now it looks like this. This is 11, this 11, this is another 11 and it is connected at this point. From here 2.5, this is another path 4, another path 2 and ultimately this 2 is coming to point B, 2 is coming to point B, 4 is coming to point B and this combination is coming to point B and here this is A. So now it is easier to understand what are the different combinations. 11 and 11 parallel, equivalent of that is in series with this one, equivalent of whole is parallel with 4 and parallel with 2. So ultimately say 11 parallel 11 equivalent of that is in series with 2.5, with that 4 parallel, equivalent of that is parallel with 2, and ultimate the calculation we got Rn is 1.14 ohm. So we got In is 100 ampere and Rn is 1.14 ohm. Putting these two values, In is 100 ampere and Rn is 1.14 ohm in equivalent circuit. So this load current IL will be opposite resistance 1.14 divided by summation of these two resistance 8 plus 1.14 multiplied by main current 100. Ultimately IL is 12.5 ampere. Now checking whether my calculation is perfect or not. This is the main circuit. This ammeter is connected to get the load current in main circuit. This is the Norton equivalent circuit with Norton current 100 ampere, Norton resistance 1.14 ohm, and this is the load 8 ohm resistance. Now running the simulation and checking the load current in main circuit and load current in Norton equivalent circuit. Running simulation. See here, in calculation my load current was 12.5 ampere, and here also I am getting the load current in main circuit is 12.5 ampere, load current in Norton equivalent circuit is 12.5 ampere. So my calculation is perfectly okay. This next problem, find the Norton equivalent of the circuit external to resistance RL. So this is the load resistance in the circuit in figure below. Use the equivalent circuit to determine the load current IL when RL is equal to 0 to 5 kilo ohm. Say RL is equal to 0, 2 kilo ohm and 5 kilo ohm. So I have to calculate the load current. This is the load resistance. So first I need to draw the equivalent circuit. This is Norton current parallel with Norton resistance, and this is load resistance. Next step, to find the Norton current. To find the Norton current, the load resistance should be removed and this will be shorted. So here see, this is shorted. Now whatever the current will flow through the short circuit path, that is the IN. Now here see, due to this voltage and this resistance, the current will flow here in this direction, and due to this current source, current will flow this direction, and summation of these two is ultimately here. Say this is I. I is having two paths. One path is this one, another path is this one. This I1 and say this is I2. Now this I2 is short circuit path and I1 is having a particular resistance, so no current will flow through this 2 kilo ohm resistance. So whatever the I, full I will flow through the IN. So we may omit this resistance while we are going to calculate the Norton current. Say I have omitted this one, so this is the equivalent circuit. Now to calculate the IN, this is the summation of these two, this one and this one. Say this is I1 and this is I2. So IN is summation of I1 and I2. Now I2 is 5 milliampere. What is I1? I1 is producing due to this voltage, and that I1 path is like this, from here to here, and this is the return path. So for I1, the only voltage source, this is 15, and only this resistance 6 kilo ohm. So I1 is equal to 15 voltage divided by 6 kilo ohm. This is I1 and this is I2. Summation of these two, ultimately we got 7.5 milliampere. This is the Norton current. Now to calculate Norton resistance. To calculate Norton resistance, this load should be removed. So say the load has been removed and the sources will be replaced by their internal resistance. This is ideal voltage source that is shorted. So here this is short circuit, and this is ideal current source, and internal resistance is infinity. So this will be open circuit. So here this is open circuit. Ultimately what we will get? We will get this resistance combination. It is very easy that when we walk from here, I got two paths. So 6 kilo ohm and 2 kilo ohm are in parallel. So equivalent resistance is here I got 1.5 kilo ohm. So Rn is 1.5 kilo ohm and In is 7.5 milliampere. Putting these two into the equivalent circuit, say IN is 7.5 milliampere, RN is 1.5 kilo ohm. Now according to question, I need to find out the load current when RL is 0, 2 kilo ohm and 5 kilo ohm. When RL is 0 ohm, 0 ohm means this is short circuit path and this is the main current. So this current is having two paths. One path is here, another path is here. The similar consideration, when this is short circuit path, no current will flow through this path, so IL will be the full current 7.5. So when RL is equal to 0, IL is 7.5 milliampere. When RL is 2 kilo ohm, then what will be the IL? IL will be opposite side resistance divided by this resistance plus this resistance, say this one, multiplied by the main current 7.5 milliampere. Ultimately IL will get 3.21 milliampere. When RL is 5 kilo ohm, using the similar way, what will be the value of load current? Opposite resistance divided by summation of two paths resistance multiplied by the main current 7.5 milliampere. Ultimately I got 1.73 milliampere. This is the load current. Now showing whether my calculation is okay or not. I am considering only one value of this RL. This is 5 kilo ohm. I am showing using the load resistance 5 kilo ohm. Say this is the main circuit. I am using load resistance as 5 kilo ohm. This ammeter will show the current through this load resistance, and this is the Norton equivalent circuit. This ammeter will show again the current through the load resistance in Norton equivalent circuit. I am using the 5K. What is the value of current in 5K? The value of current in 5K is 1.73 milliampere. This is the calculated value. Now I am showing in simulation, running the simulation. See here, in main circuit the current is 1.73 milliampere. In Norton equivalent circuit also the current is showing 1.73 milliampere. So my calculation is perfect. Problem number 7. Find the Norton equivalent of the circuit considering 6 ohm at the load. So this is the load. Use the equivalent circuit to determine the load current. So I need to find the load current which is flowing through this load resistance 6 ohm. First drawing equivalent circuit. So this is load resistance, Norton current, Norton resistance. To find the Norton current, what is the procedure? This load should be removed and we need to make a short circuit here. So this is the short circuit, and whatever the current will flow through this short circuit path, that is the Norton current. Now here, because of the presence of this source and this resistance, a current will be produced here. That current will have two paths. One is this path, another one is this path. But as this is having a resistance, so no current will flow through this 5 ohm resistance. Whatever the current will be produced by this 60 volt and 20 ohm resistance, all the current will flow through this path. So what is that current? That current is 60 divided by 20, that this is that current, and this will flow in this direction. Now another source is here, this 12 ampere source. There is the constant current source. So this is the 12 ampere current. This is having two paths. This is one path, this is another path. Similarly, this path is the short circuit path and this is having a resistance, so no current will flow through this path. So all the 12 ampere will flow through this path. So what is the value of this IN? IN is the summation of the current produced this combination and this 12 ampere. So ultimately IN I will get 15 ampere. This is the Norton current. For Norton resistance, the load will be opened. So this is load open. Voltage source, this will be short circuit. So this 20 ohm resistance, this is short circuit. Say 20 ohm resistance is short circuit. This 5 ohm is as it is, and this is the current source. This is open circuit. So now this is the Norton resistance. Here easily we can see that this Norton resistance is the parallel combination of 20 and 5. So ultimately we will get Norton resistance 4 ohm. So Norton current is 15 ampere, Norton resistance is 4 ohm. Putting these two in equivalent circuit, this is 15 ampere 4 ohm. I need to find out the load current through this 6 ohm resistance. Using the similar formula, current through this is equal to opposite side resistance divided by summation of these two resistance, here this multiplied by the main current 15 ampere. So ultimately IL is 6 ampere. So this is the answer, load current. Now showing whether my calculation is perfect or not. See here, this is the main circuit. Ammeter is connected in series with the load so that I can get the load current, and this is the Norton equivalent circuit with the Norton current 15 ampere and Norton resistance 4 ohm, and this is the load. What was my answer? Answer was 6 ampere was the load current. Now here see whether the 6 ampere will get in both the circuit or not. Running the simulation, see here, in main circuit the load current is 6 ampere, in Norton equivalent circuit the load current is again 6 ampere. So my calculation is perfect. Problem number 8, find the Norton equivalent of the circuit considering 30 ohm as the load. So this is the load resistance. Use the equivalent circuit to determine the load current. So I need to find out the current through this 30 ohm resistance using Norton's theorem. First step is to draw the equivalent circuit. This is Norton current, Norton resistance is parallel, and 30 ohm load resistance. Now to find out the Norton current, what we need? We need to short circuit this resistance. So this is short circuited. The rest sources and resistance are kept as it is. So now the current through this short circuit path is the Norton current. So this is very simple. On current will be produced by this source through this resistance, and that will flow through this path. Another current will be produced by this source through this resistance, and this will flow through this path. So from here the current is 100 divided by 50, and from here current is 180 divided by 60. Ultimately 5 ampere is the Norton current. Next, for Norton resistance, this will be open. So say this is open, this is short circuit, this is short circuit. So here this is short circuit, through this 60 ohm this is short circuit. So ultimately this is the circuit to find out the Norton resistance. It is very simple. What is here? 50 and 60 ohm are in parallel. Ultimately Norton resistance is 27.28 ohm. I got Norton resistance is 27.28 and Norton current is 5 ampere. Putting these two value in Norton equivalent circuit, say Norton current is 5 ampere, Norton resistance is 27.28 ohm. I need to find out load current. So similar way, load current will be equal to opposite arm resistance divided by summation of two paths resistance 30 plus 27.28 multiplied by this main current 5 ampere. So ultimately we got 2.38 ampere. So this is the answer, load current. Now showing whether my calculation is okay or not. This is the main circuit. Ammeter is connected here in series with the load resistance 30 ohm. This is the Norton equivalent circuit. Say the Norton current is 5 ampere, Norton resistance is 27.28, which I got from the calculation, and this ammeter is connected in series with the load to get current. What was my ultimate result? Ultimate result was load current is 2.38 ampere. Now running the simulation and see. Say in main circuit the current is 2.38 ampere, and in Norton equivalent circuit the load current is same 2.3 ampere. So my calculation is perfect. Problem 9. Find the Norton equivalent of the circuit considering 10 ohm as the load. So this is the load resistance, and we need to find out the current through this 10 ohm resistance using Norton theorem. So this is Norton equivalent circuit, IN in parallel with RN, and this is the load RL, which is 10 ohm. Next step, we need to find out Norton current. So to find out the Norton current, what we need to do? We need to short the load resistance. So this resistance will be shorted. So here no resistance is here, it is shorted. Now whatever the current will flow through this short circuit path, that is Norton current. There is a current source 10 ampere. Here this 10 ampere, it is having two paths. this is one path, this is another path. In this path there is 5 ohm resistance, but in this path this is short circuit, so this full 10 ampere current will flow here in this short circuit path. So this is 10 ampere which will flow in this direction. Now through this path another current will flow because of the presence of these two sources. This 20 volt, this is positive, 40 volt, this is positive. So this is higher voltage than this one. So a current will flow in this direction, and in this path the resistance is only 5 ohm. So what will be the current? Current will be the potential difference between these two terminals, which is 40 minus 20 divided by 5 ohm, and this will flow in this direction. So this current will flow from right to left and 10 ampere will flow from left to right. So ultimately this current, what is the value of this current? 40 minus 20, that is 40 divided by 5, this is 4 ampere. So this 4 ampere will flow from right to left and 10 ampere is flowing from left to right. So ultimately the net flow, that is IN in this direction, which is 10 minus 4. So ultimately this is 6 ampere. So IN is 6 ampere. Next, to calculate the RN, as this is the load, so this will be open. Say this is open. This is voltage source, this is short circuit, shorted. This is voltage source, this is shorted. This resistance is as it is here, and this is current source, this is open. So ultimately the circuit is this one. So value of RN is just 5 ohm. So what we get? IN is 6 ampere and RN is 5 ohm. Putting these values in equivalent circuit, IN is 6 ampere, RN is 5 ohm. What will be the load current? Similar way, this current will be opposite path resistance 5 divided by 5 plus 10 multiplied by main current. Ultimately the result is 2 ampere. So the load current is 2 ampere. Now showing whether my calculation is okay or not. What the value I got? IL is 2 ampere. This is the main circuit, as this is the load. So ammeter is connected in series with load, and this is the Norton equivalent circuit. 10 ohm is the load, so ammeter is connected in series with this one. Running the simulation, what is the load current? See, in the main circuit the load current is 2 ampere. In Norton equivalent circuit load current is again 2 ampere. So my calculation is perfect. Problem number 10. Find the Norton equivalent of the circuit considering 20 ohm as the load resistance. So this is the load resistance here. Use the equivalent circuit to determine the load current. So I need to find out the current through this load resistance using Norton's theorem. First, drawing the equivalent circuit, this is IN parallel with RN, and this is load resistance. Next I need to find out the Norton current. So Norton current is by shorting the load. So this is shorted, say this is shorted. So whatever the current will flow through this short circuit, that is the Norton current. Now to find out the short circuit current, see here this is one current source. So this current is having two paths. One path is in this direction, another path is in this direction. But in left direction current path is having the resistance, so no current will flow through this path because of this one. So all 4 ampere current will flow in rightward direction. Now for this source, another current will be produced. So this is the source, and through this 5 ohm resistance, say current is I. This I is having two paths. One is I1, another one is I2. Now this I1 will flow through this short path and it will return through this, and I2 will flow through this 10 ohm resistance. So I1 is divided into two paths, I1 and I2. I need to calculate the I1, because this I1 plus this 4 ampere, this is IN. So what is IN? IN is I1 plus 4 ampere. This is IN. Now I need to find out the value of I1. What is this I1? To find out this I1, I need to find the main current I, because this I is divided into two parts. One is I2 and I1. So I need to find out this I. What is I? I is the main current produced by this source and the combination of 5 ohm resistance, 10 ohm resistance and 10 ohm resistance. So what will be the main current I? The main current I will be this voltage divided by the equivalent resistance. So first I need to find out the equivalent resistance. How to find out the equivalent resistance? See, this is the path 5 ohm. Next it has been divided into two paths. This is one path which is returning back here. This is another path. So this 10 and 10 are in parallel. Equivalent of this parallel will be in series connection with 5. So this is 5 in series with 10 and 10 parallel. So this is the equivalent resistance. So total voltage divided by this equivalent resistance is the current, which is 4 ampere. This 4 ampere is this current. So I got the main current. Now this main current is divided into two paths. This is one path, this is another path. I need only this path. What will be this path? This path is equal to current I1. This I1 will be opposite path resistance, that is 10 divided by summation of these two path resistance. This is 10 plus 10 multiplied by the main current, which is 4 ampere. So this is that part. So this is I1 plus of this 4 ampere, and I1 is producing because of this voltage, plus of this 4 ampere is ultimately IN. So what is the value of IN? IN is equal to 6 ampere. So I got Norton current is 6 ampere. Next, for Norton resistance, the load will be removed. Say load has been removed and the sources will be replaced by their internal resistance. So current source is completely open. See here, current source is completely open and this is short circuited. From 5 it is short circuited. Say this is 5 is short circuited. All other 5, 10, 10, these are as it is. When you look from this direction, the equivalent resistance from this combination is the Norton resistance. Here what is here? This 10 ohm is in series with the parallel combination of these two. So see, 10 ohm is in series with the parallel combination of 10 and 5. Ultimately we got Rn is equal to 13.3 ohm. So what I got? IN is equal to 6 ampere, Rn is equal to 13.3. Putting these values into equivalent circuit. So here IN is equal to 6, Rn is equal to 13.3. What will be the value of IL? The IL will be opposite side resistance. This is this one divided by summation of these two. Summation of these two multiplied by the main current, which ultimately I got 2.4 ampere. So this is my answer, load current through the resistance 20 ohm. Now showing when the calculation is okay or not. See here, this is the main circuit. This ammeter is connected in series with the load and this is the Norton equivalent circuit. This is the Norton current 6 ampere, Norton resistance 13.3 ohm. What is my calculated value? IL is equal to 2.4 ampere. Running the simulation. See here, in main circuit I am getting 2.4 ampere. In Norton equivalent circuit also I am getting 2.4 ampere. So my calculation is perfect.